Alright class, so let's discuss together on the greedy algorithms. So for the practice questions here, so you're given 4 places, right? Ang Mo Kio, Bedok, Serangoon, Punggol. And we are trying to determine what is going to be the optimal tour. But we may not get the true optimal. Instead, what we're going to do is to perform greedy algorithms. Now let's try both the greedy 1 and the greedy 2. So the first part A, it says that using the first greedy algorithm with Ang Mo Kio as the starting city. So we start from Ang Mo Kio. So greedy 1 is going to expand this one city at a time. We always expand from the last included city. So starting point is A. So A, we pick the next closest one, which is Serangoon, because between Bedok, Serangoon and Punggol, Serangoon is the closest one, 4. And from Serangoon, okay, so we go on to the next city. The closest one is Punggol, which is 7. By now we included 3, ASP, so we had no other option. There is only one left, which is to include Bedok. And from Punggol to Bedok is actually 9. And then once we get to Bedok, we are going to return to Ang Mo Kio. And there's a distance of 10, right? Ang Mo Kio to Bedok. So the tour that you get from the greedy 1 is ASPB. And the total distance is, well, 30, right? So 4, 7, 11, plus 9, 20, plus 10, 30. And this is the greedy 1. Right, so now we're going to then discuss the greedy 2. So for the second greedy algorithm, we are going to start from the smallest pair. So it's not at random. Instead, we look at the table and we find which pair of cities will have the smallest distance. So it turns out that Ang Mo Kio Serangoon has the smallest one. So we start from Ang Mo Kio and Serangoon and coming back, right? So that is the first tour. Then we want to expand. To expand, then we previously, when we also started with AS, but from then we go on from S alone. From here, we try to expand either from A or from S. So if we expand from A, then the best place to expand to will be Bedok, because that is 10, whereas the other option, Punggol, will be 13. So this is one option. The second option is to extend from S. We extend from S, then between Bedok and Punggol, Punggol is smaller at 7. So then you have 2 options for expansion, either to expand from A to B or from S to P. But because this is a smaller distance, so we're gonna expand based on this option. So which means that we're going to put P next to S. Putting P next to S could mean that P comes before S or after S. So then the 2 options are APS or ASP. Well, it so turns out that for 3 cities, when the distance is symmetric, they are actually identical, because the PS and SP is the same distance, AS, same distance, AP, same distance. So it doesn't quite matter which one you pick, you just have to pick one, because they are essentially identical. So let's assume that we're going to pick this one. Then we're going to expand in the next step. Now in the next step, we are going to try to expand from each point, whether from A, from S, or from P. But actually, there is only one city left, so then we have to examine from A to B, S to B, P to B, which one is the smallest one. So A to B is 10. S to B is 8. P to B is 9. So then we know that the best expansion is to go from S by adding B. So we will put B next to S. So putting B next to S could mean that we have B before S or after S. So the two options then would be A, B, S, P, or A, S, B, P. So two options. So then we just got to figure out which one is smaller. So the SB and the SB here is the same. The AP and the AP is the same. So then we are comparing the rest. So AS is 4. The BP is 9. So that is a total of 13. The AB is 10. The SP is 7. So this is going to be longer than this one. So we're going to reject this. So this one is rejected. And instead we are going to accept this one. So then this is going to be the final tour that you get based on the greedy 2. Right? Now, so far any clarification? Yes?
You know, like a few weeks ago, Bob said that for greedy algorithms, right, it would depend on your starting point to get like a more optimal answer. So in this case, if we look at greedy 2, right, does it mean that we should change our starting position to maybe the second most, like, a second most closest pair of cities? Or would that like be unnecessary because we're already starting with the lowest, like?
That could help. I think the point here is that when you talk about greedy algorithm, there is no guarantee that you're going to get to the optimal solution. So what you get is one solution. And as much as possible, we try to make the solution to be good, but there's no guarantee we get the best one. So that is one possible strategy that you can do, which is to try a different starting point and see whether you get to a different solution. And you can try this a few different times. So that is one way of doing it. There is another way of doing it, which is going to be the follow-on algorithm.